Hi everyone, we're going to go over the calculations for the Aspirin Spectrophotometry lab very quickly here. You should have made a data table already, and you know that the molarity in each case can be calculated using MIVI equals MFVF. Final volume in each case is 100, and that final volume not only contains 40 mils of dye, it also contains these different amounts of stock, so you can calculate how much water each case must contain. The absorbance values are in the previous video if you look at the data table from the LabQuest. Now, we also recorded the absorbance of the tablet solution, and I think it was 0.267 if I remember correctly, and you'll want to get these numbers from the video. Then we have 5 questions in data analysis. The first question says see attached graph. However, I don't need you to attach your graph to your lab journal and scan it in, but you may want to look at the graph and make sure you understand what a Beer's law curve looks like, and make sure you understand that linear relationship between concentration and absorbance. If we rearrange that equation where absorbance is concentration multiplied by slope, then we can solve for concentration by taking the absorbance of the unknown and dividing by the slope of the line on that graph. And I think the slope value is something like 1300, but again, you'll want to check the video to get that value and this value, and then calculate the concentration of that unknown solution. Now, that unknown solution contained our tablet of aspirin. It was only 1/40th of the tablet, but it was also diluted to 100 mils. So if I want to know how many moles of aspirin are in that 100 mil sample that I took the absorbance of, I need to take its molarity, which I've just calculated, and multiply by the volume, which is 100 milliliters, or 0.1 liters. After that, I'll know how many moles of acetylsalicylic acid are in that sample, in that 100 milliliter sample. Next, if you look at question 4, remember that that was only 1/40th of the tablet. And so in question 4, we want to multiply that number by 40, and then in question 5, we can multiply by molar mass to get the actual grams of aspirin in the tablet. Then we're going to write a good old-fashioned conclusion, claim, evidence, reasoning, and error analysis. And in this case, there's one other question I'd like you to consider. It says, if the actual mass of the acetylsalicylic acid in the tablet were 0.325 grams, what is your percent error? And you remember the percent error calculation is the difference between your theoretical result, 0.325, and your actual result, which you calculate in your answer to question 5 in the lab, divided by the theoretical 0.325 multiplied by 100. So that wraps up this lab. Let me know if you have any questions. See you next time.